In this sample problem, we're asked what type of reaction would form 2,3-dichloropentane. What chemical was it formed from? So if we want to figure this out, what we need to do is we need to draw out this compound. We know we have a pentane base, so 1, 2, 3, 4, 5, and then we have chlorines on carbons 2 and 3. So even though I've drawn these opposite of each other, what this shows us is that we have carbons that are adjacent that have become halogenated. So this got formed from an addition reaction. We know it's an addition reaction because the two sides have both been halogenated. That means that what happened was that a double bond got attacked. So originally, the chemicals we would have had, we still would have had the same pent base, but between carbon 2 and carbon 3, we would have a double bond. So that would have been pent 2-ene that it was formed from. And the pent 2-ene would have had to react with chlorine gas. In another sample problem, we're asked to draw out the elimination reaction for ethanol. So what we'll want to do is we'll want to actually show the reaction with diagrams. So ethanol is our starting compound. So we have CH3 CH2OH. And I'm actually going to break that out into a proper diagram like this. So we have two carbons. We have an OH group on one of the carbons and not one on the other one. In an elimination reaction, what's going to happen is we're going to have one group from each atom get broken off and turned into a new compound. So it doesn't matter which hydrogen you take on the carbon on the left-hand side, but it is the hydroxyl group that will break off in this reaction, and that will become a water molecule. Right? Because we have the OH group and then we have the one hydrogen combined onto it. Then what we will get as our other compound is we will get ethene. So that double bond is being created because when you break off the H and the OH, that leaves the carbons unbonded, and the easiest thing for them to do is bond with each other.